This project will outline this design that uses multiple layers in a shoe to keep feet warm and comfortable. Each layer has a specific job, such as soft fabric, trap warm air close to skin, paraffin wax, absorb and release heat as needed, and aluminium foil reflect body heat back to foot. Gore-Tex blocks wind and moisture from outside, while rubber sole prevent heat from escaping through the ground. So, why do actually feet lose heat? Heat is naturally lost from the body through these three physical processes, such as conduction, convection, and radiation. Conduction is direct contact with cold surface that can transfer away heat from food. Convection is cold air moving around the food that carry heat away. Radiation is body heat is emitted outward as infrared energy.
Next, I would like to talk about the equation and mechanism. First, heat transfer. Thermal isolation is minimizing the rate of heat transfer from warm food to cold external environment. Soft fabric and polyurethane foam work by trapping stagnant air, while solid polymer have relatively low thermal conductivity and steel air has the lowest thermal conductivity. For thermal buffering is absorbing excess thermal energy, preventing overheating, and releasing it when temperature drops. The paraffin wax act as constant temperature thermal buffer. When feet exert energy and warm up, they reach the melting point of wax. All excess thermal energy is redirected to breaking the wax from solid to liquid.
Assalamualaikum. Today I will explain to you guys how heat transfer and thermal buffering help people stay warm in cold weather. First, let's look at the mechanism of heat transfer. The formula is Q over T equals to Ka open bracket T1 minus T2 over D. So, Ka is thermal conductivity, A is area, delta T is the temperature difference, D is the thickness of the material. This formula shows how heat moves from a warmer area to a colder area. Materials with lower thermal conductivity reduce heat loss, helping people stay warm in cold weather. Next is thermal buffering. The formula is Q equals to ml, where Q is the thermal energy stored or released, M is the mass of paraffin wax, L is the specific latent heat of reaction of paraffin wax. So, paraffin wax can both absorb and store heat when it melts, then release heat slowly when it cools. This helps maintain a stable temperature and keeps the body warm for a longer time. These concepts can be used in clothing or equipment for people who work or stay in cold environments such as skiers and snowboarders, mountain climbers, hikers, people living in snowy countries. So, the conclusion is, by using insulation materials and thermal buffering technology, people can stay warmer, safer, and more comfortable in extreme cold conditions. Thank you.
Assalamualaikum and hi, my name is Nur Intravarja. So today, I would like to explain about component of approach. First, how does the system work based on the thermal physics principles? So the system uses a thermal scanner to detect body temperature from students, and the sensor detects infrared heat, energy released by the human body, and convert it into temperature readings. When the temperature is within the normal range, the attendance is automatically recorded in the system. And then number 2 is, how are these physics concepts applied in the system? So the thermal physics concepts are applied through heat transfer and infrared radiation. human bodies emit thermal energy, and the sensor measures this energy without direct contact, quickly and safely while recording attendance outcome.
Lastly, I will explain the observed outcome of our layered thermal shoe design. Based on our observations, the layered shoe design is able to keep the feet warm, dry, and comfortable in cold environment, as each layer has its own important functions. First, the soft insulating fabrics traps air inside the shoe. The trapped air reduces heat loss so the feet can stay warm. At the same time, the soft materials also make the shoe comfortable to wear. Next, the paraffin wax is a phase change material. It absorbs excess heat when the feet become too warm and releases heat again when the temperature drops. This helps maintain a stable temperature and prevents overheating. Overall, the combination of these layers improves thermal insulation and increases comfort for the user.